a two-pointers problem session, and we are here. My name is Duke, and this is Adrian. We're currently recording right now. We will be switching off, just so that we can show you the awesomeness of geometry, okay? Alright, so our first problem for today, right, is we have a quadrilateral. It can be any quadrilateral. Doesn't matter, right? As long as it's convex. Convex meaning that it is closed, right? I'll demonstrate to you what a concave quadrilateral looks like in just a moment. Alright, so here's our quadrilateral, right? And basically the problem, right, is that if we were to draw the midpoints, right, on each point on the quadrilateral, right? And these are equal to each other, right? Now I'm using this. I'm using just one line, right? Just to note that on this segment, right, this is equal to that, and on this segment, this is equal to that. See, just to make things less messy. Okay. So basically, if we were to put any point on this quadrilateral, right? For instance, I'm going to call this point P, and the points of the quadrilateral are A, B, C, and D. Alright, so if I were to connect the midpoints to that point in it, I'm not actually too good at lines, so bear with me, please, children. My assertion is that half of this area, right, which I will call K, right, 1 plus K2 is equal to the total area. So total area divided by 2, right? If I said total area, this plus this is equal to the total area, that's my mistake. It's actually half the total area. Is equal to the area of this first quadrilateral plus the area of the second quadrilateral. Alright, so I forgot to mention what a concave quadrilateral is. Let me go ahead and demonstrate. Right, so we have a quadrilateral like this, right? And I already messed up. This is considered a concave quadrilateral. Now, this is not too important, right? Just wanted to show you guys what a concave quadrilateral is. Alright, so we've gotten this far, right? Now, just as a review, I'm going to bring up what a midpoint is, right? Basically, according to Euclid's first postulate, right? If we were just to choose 2 points, right? And connect them, point P, point Q, this would create a line segment, right? Now, what a midpoint is that at the center of it, right? Midpoint is at the point where it divides the length of this side, right? To the length of this side. So this side is equal to this side. These two sides are equal in length. Alright. So now that we have that established, let's go ahead and bring up the area of triangles. As most of you children have remembered, the area of a triangle, right, is equal to half the base times height. Alright, so it's equal to half the base times height. Cool, cool. What does this tell us? Well, the base, right, is just the length from this point, which I'm going to call B, to the length of this point, C. See, this is the base, right? And what is the height? Well, if we were to connect this point, right, to this side, and if it were to form a 90-degree angle, right, this itself is known as the altitude, but it is also the height. And the way you actually determine the area, right, is by multiplying the base times the height. Alright, so now that we have that established, you kids tell me, if you can tell me what the area, right, if I were to connect this midpoint right here, these sides are equal to this point right here, what would the area be of this triangle and this triangle? Go ahead and think for that about a second. Alright, so the area of this triangle, right, is going to equal to half the base, right? Half the length of the base. So half of the base times height. See? Because if you add up both of the lengths together, right, which is equal to, I'm going to call this point P, BP plus PC, right? These are congruent to each other, see? So if I were to take part of this, right, which is just BP, and multiply it by the height, H, I would get a quarter of the base times height for both of these triangles. They share the same height.
So basically, with what was just covered, with halving based on what was just covered, if you draw a line from each vertex to the midpoint, results in each triangles. This one shares the same base and height as this one, so their areas are equal. All lowercase k1, lowercase k2. Same is true here. K3, k4, here, and here. Which means the total area is equal to K1 plus K2 plus K3, 4, 5, 6, 7, and 8. But because 1 is equal to 2, 2 is 3, 4, 3 and 4, 5 and 6, and 7 and 8, it can be rewritten as K1 plus K1 plus K4 plus K4 plus K5 plus K5 plus K8 plus K8, which can be written as 2 K1 plus K4 plus K5 plus K8, which is equal to 2 times K1 plus K8 plus K4 plus K5, and K1 and K8 is equal to the area of this quadrilateral, and K4 and K5 is equal to the area of this quadrilateral. So the area of each quadrilateral is equal to half of the total area. And the same is true for these two quadrilaterals.